So I want to share the idea that I have and why I think it could be pretty powerful and a good way to build a nice foundation of understanding for Algebra 1 students going forward so that, again, calculus is accessible. AP Stat, they've already done some problem solving and some higher level thinking more frequently so that we can see more success, Algebra 2 kids going into AP Stat, whatever. So I think there's a lot of benefits that way. Okay, so we're talking about solving a simple quadratic like this, and some people are saying, no, you know what, we should really wait till later after we can graph these and see that we have two solutions. And I really beg to differ. Why would you want to say, well, let's take a look at this function right here, and let's graph it, and let's see where the roots are. Hey, if we're doing this problem, we're not going to do that. When we first see this particular problem right here, it doesn't have two variables, it only has one. So I don't think we'd say, well, let's go see this function over here so we can see that there's one root, that there's one solution and x equals 9. I don't think we'd dream of making that problem that difficult, taking a single variable problem and throwing it into the bivariate plane. So all we're going to do is divide by 2 on both sides. We're going to get that x equals 9. And what we can do is we can say, well, you know what, graph it. It's like, what do you mean graph it? Well, it's just the number line. It's just what the values that x could be. And so we can see that x can be 9. So let's put a point right there. That's the solution set. We graphed it. Then we can go to this bad boy right here and we'll say, okay, let's divide this by 2. Let's get that x is less than or equal to 9. We can see it on a graph, and it's just this x-axis. It's just the x-axis alone. There's the 9. We put a solid point there. X can take on any value down here. Infinite many points put together lead to a solid line. Boom, we got it right there. And now we go to this puppy. Now, granted, the initial step, the first step is a doozy, and basically it's going to be the most abstract thing. Let the kids wrestle with it. Let them construct the meaning and wrap their brain around it. Once they've done that, the rest of the procedure and what it can do, very straightforward, very visual. We can see equations emerge. So the toughest part is this part right here. We're going to take the principal square root of both sides of the equation. One of the best things we can do is say, okay, you guys, we know that the two solutions are 4 and -4. So I want you to go forward with this first time through this problem, realizing that, hey, x could be -4, so in our mind, x is -4. Now, what's wrong then with us saying that the principal square root of x squared is just x? Well, x is -4, that's one of the solutions. So we just took a principal square root of a number and we're reporting a negative number. That's not allowed in math because that's the principal square root. So in comes the absolute value function. It can take the negative and make it positive. And so it's not, oh, okay, now even if x is -4, look at this. The principal square root is a +4, not a -4. So this is how we obey what that principal square root is saying, and this is why the absolute value function is so important. Okay, then on the right side, we know there's only one principal square root of 16, and it's 4. There, the toughest part is done. That's the part that kids are going to struggle with for a little bit. But once we get here, it's like definition of absolute value. How far is the number from 4? Where is x? It is either right here or x is right here. It's 4 units away from 0. So there are two solutions. We can see that there's two solutions with one variable, just the x-axis. We don't have to wait till we go to bivariate functions and equations to do this. So what are our answers? Hey, x can be 4 or x can equal -4. And at first, it's probably wise to just do it like that. Don't write plus or minus 4. Just show it so that every time you can see the equation, you can see the two solutions. Hey, how do we solve this? No problem on. We just go reverse order of operations to peel away everything that's keeping us from finding the true value of x. Our very next step, the principal square root of this. Got to make sure we report the positive root. There's a variable involved. Oh, it's the absolute value of x minus 2. Principal square root here is 5. Definition of absolute value. How far is this quantity, x minus 2, from 0? It's 5 units away from 0. So on the x-axis, it is either sitting right here, x minus 2 is sitting right here, or it can be sitting right here. And when we say it's sitting down here, it means that quantity could be 5 units away from 0. That's absolute value. So it could equal -5, or that quantity x minus 2 can equal +5 because it could be 5 units from 0 on the right side. There's our two equations. We see them. We see two solutions. We add 2 to both sides. I'm not showing my work, sorry, for the sake of time. And we get that x is -3, or we get that x is equal to 7. Check the math. Does it work? You bet your sweet bippy. So we're showing that we have two equations, two solutions. We can see them on the graph, and we're using good math all the way through the procedure. So what are some long-term benefits from that? Well, we can talk to calculus teachers. Go ahead and talk to them about why is this a nice thing to do, to use the absolute value, to take principal square root, etc. And then in Algebra 2, we have problems like this. And some of us as Algebra 2 teachers are using a procedure that's used in pre-calc and calculus that I think, if we really stop and think, is appropriate for pre-calc and calculus, very appropriate, because those kids have the understanding and they want a shortcut to quickly evaluate certain types of problems. One's more complicated than this, so hey, it's great at that level, but thinking about that Bloom's taxonomy thing, probably not good at the Algebra 2 level, because we haven't given students a chance to really connect and understand. So now it becomes procedural. Now it becomes a lower level thing that I tend to memorize first, and hopefully there's some understanding along the way, which granted there is, but it doesn't come that quickly, and it's more abstract. So if we just continue with what we did before, then solving an inequality is almost anticipatory on the part of the students. They pretty much figure it out on their own, because how are we going to solve this? Well, we're going to take the principal square root of both sides. We know that we better report the absolute value of this bad boy, because we got to report the principal square root. Let's make that a 25. So let's suppose that started out as a 25, and now we're going to take the principal square root of 25, and so we're going to get 5. All right, so what does it mean? Well, the absolute value is the distance from 0. We're 5 units away from 0, but wait a minute. We're less than or equal to 5 units away from 0. So where can x minus 2 be? It can be anywhere from -5 to +5, because that bad boy right there has to be at most 5 units away from 0. We can see where x minus 2 would be. And now we can write a compound inequality. Where is x minus 2? Well, that quantity has to be nestled in between the -5 and the +5. Now just add 2 to all three parts of that inequality, and we get that -3 is less than or equal to x, which is less than or equal to 7. There it is. Boom. We go back to things that we've known from before. We go back to things that we understand. Math is consistent. Math is understandable. Math is visual for the first time. We can see that. And now from that previous understanding and working into this, now as we go forward, we can do more things with this. We can understand, hey, why can you look at this as being a negative quantity? What's another way to make it positive besides the absolute value sign? And we kick Fanny and we go from there. But if we look at how we can build understanding, how we can do things that will pay dividends in the future, I think that would be pretty good. So, short-term benefits. Math is consistent. That's what we can tell our students, that it's visual, it's understandable. And then as we venture into the bivariate realm, it's easier for us first to go to this function right here that is linear by nature and say, oh look, we have a function that can come downward and go upward. We make tables of values and we can see that graph is kind of like that. Now, the transition into this puppy that's quadratic and has a curve to it is a nice transition from something that has decreased and then increased as we go along the x-axis. And then, when it comes to translations of functions later on in this Algebra 1 year, it's more easily grasped initially via the linear nature of the absolute value function. So if we're jumping right into translations of quadratics, we've got to get past the trauma that is caused by having to make tables and do the 1, 3, 5 thing, and it's quadratic in nature. That's another level of abstraction. That's a veil, that's a block to keep us from really just getting to the translation part of what we're doing and why it works. So if instead we've been working with the absolute value function, it's linear in nature, it's a lot easier for kids to be able to wrap their brains around this translation, because everything's linear in nature. We don't have to overcome that right there. So those are some of the reasons that I'd really like us to consider doing this at the Algebra 1 level and seeing the benefits and just being able to build off of that idea. Thanks for listening, and I hope we could consider it, we could talk about it, and the operations don't get in the way. So anyways, thanks for your time.